Good morning everyone. So welcome back to NEET World. So in continuation to the last discussion that we have started discussing about periodic table right now. So in the last class we have discussed about classification of elements. Like what are the approaches we have and what are the different classifications we have, and the periodic models that we have seen about Dauberniers, and the next Newland's law of octave, and then next Mendeleev's periodic table, and finally this Moseley's modern periodic table we have studied right now. Then after I have explained few periodic properties like metallic nature, non-metallic nature, or I can say electropositivity, electronegativity we discussed, and how they changes across the period and top to bottom in a group, like that we have discussed right now. Yeah, so today we will be looking into few more things related to the periodic properties of elements. Okay, so now let us conclude the yesterday's discussion with these two questions. See, as we move down the group, what happens? See, as we move down the group, so let us take the color pens. Yeah, so now tell me, as we move down the group, what happens to atomic size? Atomic size increases now, they are saying it is decreases. So atomic size increases as we move down the group. So down the group means what? Like a vertical line you can take. So these are called groups. How many groups are there like this? 18 groups are there in the periodic table now. So as we move down the group, what happens? Size increases. What happens? Size increases. Okay, so it means bottom element will be bigger in size than the top element. Okay, remember like that. Next, what about non-metallic nature? See, non-metallic character increases. No, metallic character increases as we move down the group. So down the group, what happens? Metallic character increases. So you can remember most of the like metals will be more metallic nature will be at the bottom of the table. Okay, here you can remember. Okay, so as we go down the group, metallic nature increases. Okay, like that you can remember. The next thing is, so this is also incorrect. Okay, the next thing is nuclear charge. What happens to nuclear charge? We'll come back to this. Look at the next option. Metallic character increases. Metallic character increases na? Yes, metallic character increases down the group. Why metallic character increases? Because see, down the group the tendency to lose the electron is more now. So it means what happens if this is the nucleus, and let us consider these are the orbits in which electrons are revolving. Okay, so as we go down the group, what happens to size? Size increases because electrons are added into this new nth level, like new shells. So if we are adding electrons here like this, as we move down the group, what happens? See, size, see this radius is increasing or not. So it means as we move down the group, atomic radius increases because that newly added electron enters into new shell or higher energy shell. So the one which is at the last will be considered as higher energy cell. Okay, so this distance is increasing means radius is increasing, size is increasing. Okay, now if the electron is far from the nucleus, see what I am saying, if electron is far from the nucleus, we can easily remove out that electron. If electron is more attracted or more close to the nucleus, so it will be strongly binded to the nucleus. If it is strongly binded to the nucleus, we cannot remove it easily. Okay, so that's why what I am saying, the electron which is away from the nucleus, which is far from the nucleus, easily removed out. So that's why what happens down the group if we move, size increases now. So the bottom element which is having bigger size, that last electron can be easily removed. So I can say it has more metallic nature also. So why? Metallic nature depends on electropositivity. So the elements which have more tendency to be in the electropositive nature, tendency to lose the electron, that is in the electropositive nature, will have more metallic character. Okay, like that you can understand. So metallic nature increases. Now look at this nuclear charge. So this is our perfect answer for the discussion. Okay, now look at this nuclear charge decreases. Yeah, nuclear charge you can consider it as decreases because it is size is increasing now. See, here charge increases, but what happens to this electron? On the electron it is decreases. Okay, right. Next, element with maximum metallic character. What I am saying, element with maximum metallic character. Now tell me, all these are alkali metals now. So down the group what happens? Lithium, sodium, potassium, rubidium is given. So these are group 1 elements now. So down the group the element which is at the bottom will be having more metallic character. So what will be your answer? The element with maximum metallic character will be something like this. You can simply make. So rubidium will be your perfect answer for the discussion. Okay, hope this discussion is clear. Guys, if there is any confusion, please let me know in the comment box. If any confusions are there, please tell me in the comment box. I will be looking into it. Yeah. So the next, yesterday we have discussed about this table also, like if the electronegativity difference between the element and oxygen is more, then that will form acidic basic oxide. If the electronegativity is almost the same, difference is less, I can say, the difference between the element and oxygen is very less, then that oxide will form acidic oxide. That oxide will be considered as acidic oxide. If that electronegativity is intermediate, then we can get either amphoteric or neutral. Based on this, we have discussed few examples also. Now, in the exam, they directly mention these examples itself. See, you are seeing the list of oxides here now. So all these oxides they will be mentioning and asking you identify which of the following is acidic, amphoteric, neutral, like that. So it is better to make this list. See, beryllium oxide, out of all alkaline earth metal oxides, only beryllium oxide is amphoteric. Remaining all oxides are basic. Remember, this is very important oxide. Beryllium oxide is amphoteric, whereas remaining oxides of group 2, that is alkaline earth metal, are basic. Okay, so yeah, Al2O3, zinc oxide, SNO, PbO, SNO2, PbO2, Sb2O3, all these are what? Examples of amphoteric oxide. The next, so carbon monoxide is neutral, whereas carbon dioxide is acidic. More the number of oxygen, its acidic nature also increases. Okay, now next, water is amphoteric, or you can say it is neutral here. It is also considered as, okay, okay, it is a neutral. Next, what about, yeah, water is considered as neutral here. The next, what I am saying here, NO. So NO is also neutral. See, out of all possible oxides of nitrogen, NO and N2O are neutral oxides. Remaining all other oxides as acidic. What I am saying, remaining all other are acidic. Okay. Now, beryllium, like boron anhydride, boron oxide is there here. Okay, carbon dioxide, N2O5, nitrogen pentoxide is there. Okay, now out of these, which is stronger acidic? All of them are acidic oxides only, but which is stronger, like stronger, more acidic nature will be means this one. The element with more number of oxygen atoms attached can be considered as more acidic. Okay, that's it. That's it. Okay, next, isoelectronic species. In the last class also we discussed. Anyways, I will be explaining. See, isoelectronic, the species with same number of electron. What I am saying, if they contain same number of electron, then you can say it as isoelectronic species. Okay, now examples. See, sodium, if I write sodium atom, you will be saying it as atomic number 11 and electrons are also 11, but I am writing it as Na plus now. What we did here, we have removed one electron, that's why the element, sodium element becoming sodium cation, that is having now only 10 electrons. How many electrons? 10 electrons. Okay, the next, we know fluorine. What we know? Fluorine. So fluorine atomic number is 9, means it has only 9 electrons. But what I am doing is I am adding one electron, so it becomes F minus. Now how many electrons here? 9 electrons previously it has in the atomic state. Then I added one electron, so it becomes 10 electron. Okay, similarly similarly, when you consider oxygen, so oxygen atomic number is 8. Okay, it means it has 8 electrons. Now by adding 2 more electrons, it becomes O2 minus. Okay, right, now check how many electrons are there. 10 electrons are there here also. Okay, 10 electrons are there here also. Now from magnesium, I am removing 2 electrons. See, magnesium atomic number is 12, so I am making it as plus 2. Okay, so what happens? 10 electrons. Now identify, all of them are having same number of electrons or not? Yes, same number of electrons are present in the species, means they are considered as isoelectronic species. Okay, now this is one of the most frequently asked question, most commonly asked question in your NEET, JEE, EAPCET exams. Now they will make a question like this: arrange the following species in the increasing order of their sizes. okay, which is smaller size, which is bigger size, they will ask, okay, by giving this isoelectronic species. Already I discussed about this size order, how can we identify. So always I told you anion will be bigger in size, then atom, then its cationic form, like this we discussed. Right now, since all of them are isoelectronic species, means same number of electrons, okay, same number of electrons are there now, you can make it like this. Size is inversely proportional to nuclear charge. So more is the nuclear charge, smaller is the size. Once again, more is the nuclear charge. Nuclear charge is nothing but positive charge, okay, more positive charge, smaller size, okay. So more positive charge, smaller size you are saying means more negative charge, bigger size, you can also understand like that now. So which is more positive charge here? Magnesium. So this will be no smaller in size. So magnesium, smaller size. Then next this one sodium, okay. Next some more negative, see, more positive charge, smaller size, more negative charge, bigger size. Why bigger size? See, if this is the size of an atom, when you are adding electrons, what happens? That electron cloud will be expanded like this. See, if you are adding electrons here, what happens? That electron cloud expands and size becomes bigger. So that's why what I am saying, more the negative charge, larger is the size, okay, right. So you can take here F minus and finally here O minus 2. So this will be your final answer for a final conclusion of the discussion, okay. Is this clear, guys, everyone? Okay, then next we will be discussing about, yeah, so this is about, if you observe, this is about ionization energies. So how can we answer this kind of questions, okay. Let me explain you first the ionization energy and what it is exactly, then we can answer all these things. Write the heading as ionization energy, ionization energy. Okay, in the short form you can represent it as IE. Okay, so see, the minimum amount of energy required to remove an outermost electron of an atom of a neutral gaseous isolated isolated atom. Okay, it means, for example, elements can exist in any of the physical state right now, but when I speaking about ionization energy, that must be in which form? That must be gaseous form. It means first you convert the given element into its atomic form and also into its gaseous form. Okay, let us say A is in the solid form first. Now what we need to do first? Convert that into the gaseous state, isolated form. Okay, and now after converting it into its gaseous form, now element A we have. Okay, now it is in the gaseous state. Now from here, how much energy it is requiring to remove the valence electron of this atom? So if I remove the valence electron of that atom, it becomes A plus. Okay, so let us say this is an atom having valence electron like this. Now the amount of energy required to remove this valence electron is called ionization energy. Since I am using the energy from outside to pick out this electron, so you can say ionization energy is endothermic process. Which process? Endothermic process, because we are supplying the heat energy to the system now, so it is considered as endothermic. It means enthalpy should be written as positive value. There will be some positive value. Okay, if the electron is coming out easily outside, so less amount of energy is required. Okay, it means more electropositive elements, like for example metals are electropositive, we are saying now, therefore metals easily loses their electrons, therefore removal of electron from metals is easy. Right now, if it is easy, less amount of energy is required. So I can say metals have low ionization energy. Once again, metals have low ionization energy because they will lose electron very easily. Whereas if we consider non-metals like halogens, oxygen family, okay, so they won't give the electron, they only wanted to gain the electron so that they become stable inert gas configurations. Right now, for example, fluorine atom is there, so it has electronic configuration something like 2s2 2p5 in the valency. Right now, if I add one more electron to this, it becomes 2p6. All orbitals are fully filled right now. So in order to make that, in order to gain that stability, fluorine atom try to gain the electron instead of losing. So the electron removal of electron from fluorine is highly difficult and it requires high amount of energy. So simply we can conclude like this. So metals have low ionization energy, whereas non-metals have high ionization energy. Why? Because metals loses their electron easily, so they can be in the positive nature. But non-metals tries to gain the electron, removal of electron from them is very difficult. Okay, I hope up to here it is clear, right? Now let us discuss about this. Okay. For example, sodium I am taking here. Okay, sodium metal we know it is in the solid in form first. Convert that into gaseous form, then remove the electron here. So it is removed, electron is removed and it is becoming positive charge. Okay, one electron is removed. Okay, during this process I am using some amount of energy, that is delta H1 I am saying. Okay, right. Next, here how many electrons we have? Initially 11, atomic number 11 means 11 electrons will be there right now. So what is that electronic configuration? Like 1s2, 2s2, 2p6, 3s1. So if I remove this extra electron from the sodium, it becomes sodium cation, which is having this inert gas configuration like 2s2, 1s2, 2s2, 2p6, like 10 electrons, like neon gas configuration we got here right now. So that's why alkali metals loses their electron and becomes noble gas configuration. Okay, that's why they have low ionization energy. Okay, right. I hope up to here it is clear. Right. Next, one more thing, an atom A is there. If I remove first electron from it, it becomes A plus. So this is called IE1. Okay, now IE1. I am removing one more electron from here, it becomes A2 plus. So this is called IE2. Okay, and I am removing one more electron from here, it becomes A3 plus. So this is first ionization energy, second, third, like this you can understand. Okay, right. Now what I am saying, always remember IE1 is smaller than IE2. So successive ionization energies increases, you can say IE3 will be greater. Okay, like this you can understand. Okay, right. Next, let us move forward then. Okay, yeah. Next. Next, up to here it is clear now. Now they will ask you a question like this. Let me show you the question here itself. So they will ask a question like this. First ionization enthalpies of beryllium, boron, nitrogen, oxygen follows the order. So they will be giving you like this. So it means you need to know what are the variation, how the ionization energy varies across the period and down the group. Okay. So when you move like this in the horizontal row like this, if you move, what happens is ionization energy increases. Okay, increases. Okay, there will be some alternations, but overall conclusion, it increases. From left to right, what happens to ionization energy? Increases, you can remember. Now from top to bottom, what happens to ionization energy? Decreases. Ionization energy decreases. So why decreases? So the first question that I have explained here. What is the first question today we discussed? Here we discussed about a question now. Let me show you that. This one. So what we discussed? Down the group size increases now. Yeah, size increases. Nuclear charges, actually nuclear charges increases, but effective nuclear charge decreases, you can remember. Okay, nuclear charge increases they mentioned now. So now what I am saying, so size increases now. Let us come back to here our discussion. See, if this is the nucleus, okay, so let us say like this we have. Okay, so now the bottom element here, lithium, sodium, potassium, rubidium, if you say, so the bottom element having bigger size now. So bigger size means electron is far from the nucleus. If electron is far from the nucleus, I can easily remove this electron now. So I can say ionization energy decreases down the group. The bottom element electron is easily removed out, therefore it has lower ionization energy. Okay, and this is having higher ionization energy. Okay, down the group ionization energy decreases. In a short form you can make a note. Okay, right. Okay, right. Now let us discuss how it varies in a period. Okay, now second period elements you take. Second period elements, what are the second period elements we have? So you can say lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, you can take up to here. Okay, right. So here actually what I told you, ionization increases, ionization energy increases. It means ionization energy will be highest for noble gases, you can write here. Okay, noble gases will be highest. So keep it as it is like this. The next fluorine only. Okay, now when it comes to oxygen and nitrogen, generally what we consider, oxygen will be having highest because it is at the right side. But not only that non-metallic nature or electronegativity, but also their electronic configuration we need to consider. So now what is electronic configuration of nitrogen? It is like 2s2 2p3 right now, whereas for oxygen it is 2s2 2p4. So from where we can remove electron easily? Yeah, we can remove electron easily from the from this oxygen, because nitrogen is having, see what kind of electronic configuration? Half-filled electronic configuration. So due to the half-filled electronic configuration of nitrogen, it is stable, therefore removal of electron from nitrogen is difficult, therefore it is having more energy, more ionization energy than oxygen. Okay, nitrogen then oxygen. Okay, after this between boron and beryllium, carbon, you can write carbon first. Between boron and beryllium, how can you see? Here it has 2s2 electronic configuration, and for this 2s2 2p1 electronic configuration is there. So now how can you answer here? See, what we think, boron is at the right side, so it will be having highest. No, here again see the valency electrons are in s orbital now. See, s orbital is more close to the nucleus. We can say it is a penetrating power of s orbital. Since s orbital is a spherical in shape, it is closely bound to the nucleus. Therefore, electrons present in the s orbital is strongly bound to the nucleus. They won't come out easily. They require high amount of energy. Therefore, removal of electron from beryllium is difficult. compared with the boron. So that's why beryllium, next boron, and least is alkali metal, that is lithium, like this. Okay, I hope it is clear. The exceptional cases here, what are the reason? Because of their half filled half filled configuration here, and here you can see penetrating capacity of s orbital. Okay, this is the story of second period elements ionization energy. Most commonly asked question this is. Okay, every year there will be a question on this ionization energy. Okay, in any of the exam, whether it can be NEET or JEE or EAPCET, you might be seeing a question related to ionization energy. Okay, particularly it will be from second period or sometimes about third period. So third period elements also follows the same trend whatever we discussed for second period. Now you tell me what will be your answer for the third period. Here I am mentioning all the elements. You just give me your answer in the comment box. See, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Okay, take these elements and mention your answer in the comment box. Okay, right. So yeah, someone in the chat box is answering. Yeah, it's perfect. So what is the answer for this question? Here option 2 is there, na? That is your answer. Okay, now the same question can be asked in the other manner also. Let us look into that model also here. Yeah, so look at this, try to match these values. Yeah, so anyone can try to match these values. See, what we know, this is the electronic configuration of what? Beryllium, right? So this is the electronic configuration of beryllium. Okay, so electronic configuration of elements is given and they are asking us to match with their enthalpy, ionization energy. Okay, so now look at this. 2s2, 2p2, 2p4 means 2s2p 2p4 means what is this? This is oxygen, because 8 electrons are there, that is oxygen. And what about this? This is nitrogen, 7 electrons are there. Here it is 5 electrons are there, boron. So now what we know, out of these, nitrogen is highest, after that oxygen, the next boron, next beryllium, least is boron, right now. So based on this you can match them. Okay, so D should be minimum value. Where do we have minimum value? So first option. Next, maximum value for nitrogen, C should be maximum value. Here is a maximum. After that oxygen should be there, yes, oxygen. Okay, and finally A here, that's it. So where do we have such option? So D, D1, 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 everyone is D1. Next, highest is for nitrogen, C4, 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 only one option we have, so go with that. Okay, C4, A3, okay, no, C4, let's see once again. We will be going with this one, C4 we have only here, then definitely this should be our answer. Okay, the next, this is for oxygen now. So what is the thing we have discussed? See, neon maximum, next fluorine, next oxygen, next nitrogen, and the next beryllium, carbon, beryllium, boron, right? So like this we have. So based on this you can answer. First should be this one, nitrogen. So where do we have highest values? C4. So C4 is only one option, that is your answer. Okay, next B3, yeah. So don't think about these options, maybe here it is wrong, but what will be your answer, perfect answer for the discussion? C4, because I have created this question using ChatGPT, might be these options are went wrong, but this will be the scenario. So C4, the next B3, okay, the next A2, next D, 1. Okay, that's it. This is your perfect answer for the discussion. Okay. Right, let's move forward then. So this is periodic table and classification of elements, and one more periodic property we need to discuss is electron affinity. What I am saying, electron affinity are also considered as electron gain enthalpy. So what do we mean by electron affinity or electron gain enthalpy? Means the tendency of an element, let us say A is an element. Now, okay, now see, if A is an element, now the tendency of an element to gain the electron, for example A is an element here, now I am adding one electron. If we remove the electron from atom, we call it as ionization energy, right now. So now I am adding the electron to this. The amount of energy change, that is the enthalpy change accompanied during the addition of an electron to an atom is considered as electron gain enthalpy. Now how much energy released or absorbed when an electron is added to an atom is called its electron gain enthalpy. Now what happens to the atom? I am adding electron now, so it becomes A minus. Okay, so during this process sometimes it might be releasing the energy, sometimes it is observing the energy, right now. So that whatever the energy change is there now, so that energy change is called electron gain enthalpy, electron gain enthalpy. Okay, like this we can write. So for most of the cases we will be seeing first electron gain enthalpy will be negative value. Okay, so what is this negative value, positive value means? For example, I am saying chlorine atom is there. If I add electron to this, what I am saying, if I am adding electron to this, it becomes a Cl minus. So during this process, it will be releasing around 340, I think 349 kilojoule amount of energy is released. Okay, so this much amount of energy means released, I am saying that should be indicated with negative symbol. Okay, for example, if you are adding same electron to the noble gases, they won't want to take that electron because noble gases are already stable right now. So noble gases are already stable. If you are trying to force this electron to enter into the atom, that won't go inside right now. So it means you need to use more amount of energy on it to push into this atom right now. So it means you only supplying the energy while you are adding this electron to this noble gases. Therefore here you are going to see a positive value. So if the element has tendency to gain the electron, their electron gain enthalpy values will be negative. Whereas if the element has no tendency to gain the electron, they will be having positive electron gain enthalpy values. If it is having tendency, negative enthalpy change. No tendency, positive electron gain enthalpy. Okay, like this you can remember. So now what do we mean by electron affinity? Yeah, if the element has more tendency to gain the electron, you are seeing a negative value now. So it means that element is having more tendency to gain the electron, or you can say it has more electron affinity. Okay, now they will give you options like this. Okay, so they will give you options like this: chlorine, bromine, iodine, which is having more electron affinity. So more electron affinity means what? The ability to gain the electron, the ability to accept the electron is called electron affinity. So who is having more electron affinity here? If I ask, you should mention chlorine, then next bromine, and the next iodine. So you can simply understand this. Down the group, electron affinity decreases. The tendency to gain the electron decreases as we move down the group, because bottom elements are having less nuclear forces on the valence electrons, or I can say it can be having more metallic character also down the group right now. So the element which is at the top generally observed to have more electron gain enthalpy, okay, or more electron affinity like this. Okay, sir, you are only discussing from chlorine, why not from fluorine? Yeah, I will be adding here from fluorine because there is a story here to understand, that's why I ignored it. Bromine, iodine. So now out of this, sir, which is having more electron gain enthalpy means here also, see, as per our discussion what we thought, down the top element should be have more affinity, means it has more electron affinity, means it should be highest, then next chlorine, then next bromine, then next iodine. This is what we have considered. But you know, after accepting the electron, fluorine becomes fluoride ion, chlorine becomes chloride. Like that, all of them becoming anions. Okay, so when you consider the ion here, fluoride ion, so small size, fluorine is smaller size now, chlorine is little bigger size. So due to the small size of fluorine, it cannot accommodate this negative charge properly. There will be electronic repulsions in it. That's why relatively fluorine is having less tendency compared with the chlorine. Okay, so that's why the overall order here becoming something like this. First chlorine, then next fluorine. Okay, right, like this you can remember. So now I will give you one conclusion here. The most electronegative element in the periodic table is fluorine, whereas more electron affinity containing element in the periodic table, if someone asks you, you should mention it as chlorine. Electronegative element fluorine, electron affinity element chlorine. Remember this, one of the important thing to remember. Okay, right, hope it is clear. Now this is also a most frequently asked question in the previous exams of NEET, JEE and EAPCET. And one more question they will be asking us about oxygen family also. Oxygen, sulfur, selenium, tellurium they will be giving, and they will asking us to arrange them in the electron affinity order. So as we discussed like chlorine and fluorine, here also sulfur will be highest. Okay, but this oxygen is having energy almost lesser than all these elements, sulfur, selenium, tellurium, and least is oxygen. Okay, you remember these two orders, two group, 17th group order, 16th group order, important these are. Okay, next. Okay, now what I discussed, affinity is over. Now affinity across, like top to bottom, it is over. Now what happens across the period from left to right? If we move left to right, what happens? These are non-metals, these are metals. So generally non-metals have tendency to gain the electrons, metal have low tendency or no tendency to gain the electron. So as we move from left to right, what happens? Electron affinity increases. Okay, the elements which are at the right side have more affinity to gain the electron compared with the left side elements. Okay, right. So yes, Nikita Vijay is asking about, sir, is this useful for 10th class? So dear students, we are making this content connecting to the class 10th to class 11. Definitely this, whatever the discussion we are doing are useful for your preparation. Even if you are in 10th class or moving to 11th, these sessions highly helpful for you. Okay, right, because periodic table classification of elements is there from class 10th itself. You should be aware of all these topics, then that will be easy and comfortable when you are moving from 10th to 11th. Okay, so that's why we are conducting these summer bridge courses for making the student to have that smoother transition from class 10th to class 11th, and whatever the concepts that comes in 10th, you should get a strong foundation and strong clarity over the subject. Then you can easily survive and score better in the upcoming exams like NEET, JEE and EAPCET exams. Okay, right. Now if you have any confusion, please let me know in the comment box. If no confusion, we will be stopping this session, and in the next class we will be beginning our discussion on chemical bonding and all other topics that are remaining. I told now I will be covering maximum chapters. Here itself I will be making every chapter to be connected with the class 10th, right? So you just follow these sessions every day. If you are new to this, click on the subscribe button and share with your friends. Thanks for watching. Stay connected.